Yeah, it'd be John, then Justin. Okay. And then also soft one, I see you sent an answer here that has like join. We're not gonna have join on this exam. Okay, so we just did. Let me go back here. We just did lambda functions. We did sorted and sort. Um, we did parameter passing. We did printf statements. So now we said we're going to do list comprehension. Okay. So list comprehension is just a easy and compact way to create lists. Right. Where you can basically make whatever list that you need, whether that be just a normal list, a nested list, any type of list. You can make them in just like one line. Okay. And to do that, you use list comprehension, where this is the general format of it. You have, obviously, we're working on lists, so you're going to have your bracket. You're going to have first, number one. You're going to have some expression. This is going to be like the result that you want to put, the result or the value that you want to put at some specific index. That's the expression. Then you have like the for I iterable. That's number two. And then for the third one, I'll put it like this since it's optional. You have some if condition, meaning if some condition is true, then you put the value in the list. Okay. Yeah, basically what Andrew just sent. So do this for this collection in this situation. Okay. So let's start off with some examples. Let's say I wanted to create a list that contains the numbers 0 to 9. How would I do that with list comprehension? Someone wants to unmute their mic or they can put it in the chat. And by chat, I mean the chat for the voice chat. List containing the numbers 0 to 9. Yep. Right. You could see what Itchy sent. He used X for X in. Well, yeah, don't do that. Yeah, I didn't even realize what you just said. Yeah, do range. Could someone else send one with range? Or if Itchy, you want to correct it if you want to. Yep, X for X in range 10. Right. Now we don't have any condition here, right? So we're just saying for every X in the range 10, put that X in the resulting list that we're making. Right. So again, we have like L is equal to, I like to use I, so I for I in range 10, right? And you can use whatever variable you want. It just needs to be the same variable that's here as well. Okay. And now, how can we change this if we say, okay, I want the numbers from 0 to 10, but I only want even numbers, right? Well, remember, you're going to be using third portion, the if condition, where you say I for I in range 10, and you only want to put it if it's even. So we're saying if I mod 2 is 0. Okay. All right. You can also do set comprehension. Oh, that's cool. I didn't know that. Good to know, but that's not something we need to know for exam one, so we're chilling. All right. So this is pretty much the basics of list compression or comprehension. Sorry. There's not much else to it. You can put the if statement at the beginning, right? That would still be valid. Um, I would only do that if you're having like two different scenarios, right? Where for every single value in that range, you're gonna have something. So like let's say you want let's say you want the numbers 0 to 10 that are even, and for the numbers that aren't even, you want a -1, right? You can put like a ternary operator in the beginning if you wanted to. So you could say like L is equal to I if I mod 2 is equal to 0, else -1 for I in range 10, right? This works. Yeah, like what did you send as well? Um, but that if statement, that's just a ternary operator, right? So it's not like we're moving the third part to the first. That's still just a value. Yeah. Okay. The else statement forces it to be in the beginning, right? Yeah. I mean, because I think for the condition on the third part, correct me if I'm wrong. I don't believe you're able to put like else or else ifs. Um, or Andrew, I don't know if you know. I think you can just put like if something. I'm not entirely sure. If you want to use like if and else, then you can use a ternary operator in the beginning, but that still evaluates to a value. There's a workaround for elif. Hmm, I did not know about that. You do nested if statements. Oh god. Yeah, I don't think that's something that you need to know. Okay. So yeah, that is pretty much the basics of list comprehension. If we wanted to, we can get into like 2D lists as well. So like let's say we wanted to use list comprehension to make a 2D list containing all zeros of size n by n where n is 3. That's easy to do as well. Where we can just go over here, say L is equal to, this is 2D, so 0 for I, for I in range 3 for J in range 3. Right. And this would give us 0, 0, 0, 0, 0, 0, 0, 0, 0. All right, so this gave us a 2D 3x3 list containing all zeros. Okay. So, any questions about list comprehension? Again, there isn't really much to it. You just need to follow that structure where you have a value, then you have the iterable, and then you have an optional if statement. And again, if you like have some like extravagant like if statement that you need to make, you can just make a ternary operator with nested if statements in the beginning portion. But just be careful when you do that, right? Because if it, I believe if you can you also short this list? What do you mean by short this list? Do you mean do you mean sort? I don't know how you would sort a 2D list where each sublist has the same values. like 3, 0 for I in range 3. Oh, like shorten it? Yeah, you can do that too. Yeah. Which we'll get into the list like operations like that in a bit as well. Okay. All right. But yeah, any questions about list comprehension? Pretty simple stuff. Um, there's not much to it. If you guys have like an example that you want me to do, I can do that. You guys can try throwing one at me and we can see how it is. Might as well do um that is incorrect. Because that would just be a list of 9 that would just be a list of 9 sub lists containing zeros. It wouldn't be 9 times bracket 0 bracket like you said, Itchy, because you see how he has like a sub list there of zeros. So it would just be a list of 9 sub lists containing zeros. Yeah, like you said right there. Yeah, you can also do it the other way around, but it's a bit easier to read. Prefix. Uh, this works. Yeah, that works. That works. Okay. All right. Which again, we'll go more into that stuff right now. But just any questions for now on list comprehension? Some people typing. Good. Okay. So some typing. um, it does, but each element. Okay. Yeah. So no more questions. All right. So now we'll go into some list operations. Um, let me move down here. All right. So some different list operations. Um, lists can do operations with plus and the asterisk sign or multiplication. Right. With the asterisk sign, it's pretty simple. It's just appending two lists together. Right. So let's say I take the list 1, 2, 3, and let's say I take the list 4 and 5. That is just going to give us 1, 2, 3, 4, 5. Okay. Pretty simple stuff. Now, let's say if it were to be the list 1, 2, 3 plus and then some number, um, I don't think that's a valid operation. I think for list addition, both sides have to be lists. I don't know if someone can correct me on that. Itchy, do you know or no? I want to make sure before I say something that's incorrect. Yes, no. Anyone know? Yes, you can do that. Let's see. No, I'm saying 1, 2, 3, and then some constant. So like 4. Yeah, see, that doesn't work. That's what I was asking. Yeah, so you can't do that. So each side of it has to be a list. Okay. Um, well, multiplication is a bit different. Where you basically take some list, and or like some list of, uh, yeah, some list of values, and it's basically going to repeat for however many times you put some constant. So let's say I put like 3 times I'll use the example you guys were using, 0, right? This would equate to a list containing 3 zeros, right? Because you're saying 3 zeros, right? But if I were to say 3 times 0 zeros, like kind of something like that, this would give you 3 subarrays containing zeros, right? Which this is something he can ask you guys. He can like give like some complex versions of these and say like, what is the output, right? Here's another one. Let's say if we had 3 times 0, right? What do you guys think that this would give? Will he ask the output type questions? I don't know. There's no way of knowing. He can. 3 of 3 zeros tuple. There's no tuples here. 0, 0, 0. Correct, but that would also be within a list. So that would be like 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay. All right. And then now, what would this give? Oh, sorry. What would be the result of this? Yep, correct. Are those 9 zeros? 1, 2, 3, 4, 5, 6. Yeah. Okay. Yeah. So I don't want to write all that, but these are 9 zeros. Okay. You put 3, 0. Where did I put that? Oh, sorry. My fault. Okay. All right. And then what would you get if I did this? Yeah. What would I get? You should be able to read this. Think about it for a second. What do y'all think? And don't send your answer. Just tell me when you have your answer. Just put got it. Save your answer for now, and we'll go over it, and then see, and then you guys can see if you got it right or wrong. Just say when you think you have it. Got it? Okay. Everyone else, you're good. All right. So with a question like this, we have to start from the innermost bracket. The innermost would be these over here, right? And with this, we kind of have to work with the rules of PEMDAS, right? Where we have multiplication and then we have addition. So here we have 2 times a list containing a 0. That is just a list containing 2 zeros, right? And then we have plus a list containing 1. So that's going to give us 0, 0, 1, right? So 0, 0, 1. right? I'll write it like this. Okay. And then from here, we're saying we have 3 of these, right? So I'll go like this. We're saying that we have 3 of 001s, right? So this is going to be a list containing 0, 0, 0, 1, 0, 0, 1, 0, 0, 1. Think that's correct? Or would it just be sublist? I don't remember. I think that's good. Right? Okay. If someone can correct me, that should be correct. Sublist. So it would be like this. Yeah. Hmm. Oh yeah, because if it's one value, yeah, my fault. If it's one value, then it's just one list. If it's multiple values, then it's a sublist. Sorry. Okay. Um. Yeah, basically what I just said. Yeah. If it's one value, it's just its own list. If it's multiple, you break them up into sublist. Okay. So here we're gonna have 0, 0, 1, 0, 0, 1, 0, 0, 1. That closes there. That closes here. Okay. Now this is where it gets fucky. Wait, actually, it closes here, closes here, closes here. Okay. And then now we're saying 3 times this, right? So this is going to be long. We're basically saying 3 of this whole part here, right? So this is going to be 0, 0, 1, 0, 0, 1, 0, 0, 1. Then we have one more. Yep, it's good. Okay. And this should be correct. Right, where we went into here, we got 2 times some list 0, so that just gave us a list containing 2 zeros. We appended that with a list containing 1, so we got a list containing 0, 0, 1. And then from here, oh yeah, I see, yeah. This, wait, yeah, this was supposed to be like this. Yeah, sorry about that. Okay. And yeah, that's why the sublists were there. Okay, yeah, sorry, my fault. So yeah, from here, we got 0, 0, 1, and then we said 3 times this portion here, 001. That got us this whole thing here, right? So we got a list containing 3 sublists containing 001s, and then we said 3 times a list containing 3 sublists containing 001, and that got us this. Okay? And that is the answer to that. Right? Any questions about that? Right. And I think I have one more example for you guys. Because I know this is something he asks, so this is good to know. One second, let me find it. Where is it? And I wrote it down here somewhere. Okay, here it is. Oh, this is basically what I already gave. 3. Okay. I mean, let's try this one. This is pretty much what I gave already, but let's try it. So we have 3 times 2 times 1 times 0 plus 1. All right, so try it yourself first. Just say when you got it, and then we'll go over it. And then after this, we'll go on to something else. Oh, actually, we'll go over the difference between append and extend. I know that he'll probably ask that too. Will he give us the same thing, like extra credit, like he did? Yeah, there's gonna be 140 points available. You're able to choose which questions to answer. That's what he said. Mm. All right. Waiting for one. Got it. And then we'll start this one. This one's very similar to the previous. I think it's just like 2 numbers are changed. Finished? Okay. So again, we go to the inner. That's this one right here. Okay. And we see it's 1 times 0. That's just a list containing 1 0 plus 1. So that is a list containing 0 and 1. That list is within another list that is being multiplied by 2. And that is within a list that is being multiplied by 3. Okay. Within this 2 list, we're saying that this will occur 2 times. So we're saying we're going to have 0, 1, 0, 1. Sorry. Okay. And then here we're saying that this is going to appear in a list 3 times. So it skips a set of square brackets. Where? Did I skip one by mistake? Are you saying like these two? Yeah, I didn't skip anything, I don't think. The 2 just applies to the inner bracket. Well, remember, we can have like 2 times 0, and we can also have 2 times 0, like this. This gives 0, 0, and this gives 0, 0, right? That's what's happening here, where this part equated to the list containing 0, 1, right? But we were inside of a list that's being multiplied by 2. So that's why this is inside this list being multiplied by 2, right? Where, let's say I highlight it, this here equates to this here, right? These here, they stay here because we haven't equated anything with that 2 yet. Okay? Does that make sense? Yeah. All right. And then now we're saying that we have 3 times a list that contains this over here, right? So we're saying that we're going to have this like this 0, 1, uh, 0, 1. We're saying that we're going to now have a list that contains this 3 times, right? So that's just going to be like this. That's it. Okay. All right. Did you guys get that answer? Good. Okay. Would 2013 equal 013013? It should, I think. We could try it out though really quickly, just to make sure. So you said 2 times 013, and it's correct, right? But if you were to say, like, put a bracket here, that's going to give us a list containing 013, comma, containing a list 013. There you go. Okay. All right. So any questions about list addition and list multiplication? Again, you need to be able to read this because you'll probably have some questions like this, like what is the output? Okay. All right. Another important thing to know about lists is append and extend. Okay. Append just takes 2 lists and it puts them together. It's the same thing as it takes one list and some other value and just puts it at the end of the list. Right? So let's say I have some list 1, 2, 3. And I say append the value 4. This will give you the list 1, 2, 3, 4. Right? It's just putting stuff to the end of the list. Let's say I had the list 1, 2, 3 dot append, and within the append I give it the list 4, 5. Then that's going to give us 1, 2, 3, the list 4, 5. Okay? So that's append. Pretty simple. It just takes what's in the parameters and puts it at the end of the list. With extend, it's the same thing as list addition, where let's say I have some list 1, 2, 3, and I say extend 4, 5, 6. This will give the list 1, 2, 3, 4, 5, 6. Okay. And I'm pretty sure the parameter for extend must be a list to be able to work, or else you'll get an error. But pretty much the same thing as the addition operation. Okay. So any questions about append and extend? Would extend work with a two-dimensional list? Well, you're gonna get, let's say, you're saying if you did 1, 2, 3 dot extend 4, 5, 6, like that. So yeah, so you're gonna get 1, 2, 3, 4, 5, 6. That's what you're gonna get. Okay. Any other questions? All right. So another important thing about lists is deletion and copying. Go over deletion first, and then we'll go over copying. So deletion, we use this keyword called del. Now, del is used to delete something from memory, right? This could be some variable. This can be some value from a list. This could be whatever you want it to be, right? But you have to ensure that you are dealing with those values in memory appropriately, right? So let's say I have some list. This wants to be annoying. Let's say I have some list L. Let's say it's equal to 1, 2, and 3. Okay. And let's say I want to delete the number 2. If I want to delete the number 2, I have to find what the index is. Here we know it's 1. And then we can specifically delete it by saying delete else of 1. Right? So we say delete else of 1. And this will get rid of that too. So this will make L become 1, 3. Right? But notice how now that we've done that, 3 is now at index 1. So this gives something unique because now let's say you wanted to delete the first 3 values of some array, right? Intuitively, you would think, okay, I'm going to make a for loop and we have some I values that go from 0 to 2. And for each I value, we just say delete else of I. So we're just saying delete else of 0, else of 1, and else of 2, and we call it a day. That's obviously not going to work. Why is that not going to work? Well, because let's say I have this list 1, 2, 3, 4, 5, and 6. Now let's say we're going through some for loop, looks like this for I in range 3. Let's say in this for loop we're saying delete else of I, right? So we know that I is starting at 0, right? So we're going to delete what's there. So that's that 1. And so from there we're going to get 2, 3, 4, 5, and 6, right? But then on the next iteration, I becomes 1. So now we're looking at this 3. We delete that, and then we get 2, 4, 5, and 6. And then on the next iteration, when I becomes 2, we're looking at the 5. So then we delete that and we get 2, 5, or sorry, 2, 4, and 6. Right? And this is not what we wanted. We wanted to delete 1, 2, and 3, but instead we deleted what the wrong items. We deleted 1, 3, and 5, and now we're left with 2, 4, and 6. Right? And so this is not how you do it. Right? If you wanted to delete stuff at like some specific index, the best way to do it is starting from the end, right? Because if you're starting from the beginning and you're like traversing to the right, you're deleting stuff and then you're making stuff move over to the left, and that's changing their indexes or indices, sorry. And that, causes some negative side effects, right? Or you can delete by splicing, which I believe that would work. Where you can say delete, and you want to delete the first 3, so you can say delete L sub uh, dot dot 3, and this should also work. Where this will get rid of these, and then L will just contain a list of 4, 5, and 6. Okay. So you could be tested on this. You could be like, you can be given some program, and you should be able to tell like what the output of the list is going to be at the end after running some delete functions, and you should be able to tell that. Delete -3. Uh, what do you mean, itchy? Delete starting from -3. Oh wait, how would you delete the first 3 starting from the end? Oh yeah, sorry, yeah, that's correct. My fault. Okay, right. You can also do a for loop and delete I. Yeah, you could just have I start at the last index, go 3 down, and there you go. Yep, just like you said. All right, so that's delete. Any questions about delete? Any questions about the side effects of delete? Or like, you guys want like an example question that he could give? Anything like that? Good. All right. So now we're going to quickly go over copy. I'm not entirely sure if you'll ask that, but it's something good to know. Will a while loop which condition wait will a while loop with condition is length L greater than 1 and each time it deletes 0 also work? Um Delete 0? I'm assuming you mean delete else of 0. I mean, you can have like a counter. You could say like, well, counter is less than 3, and then just say delete else of 0 counter plus plus. That can also work. I don't see why not. Okay. All right. So now we're gonna go over copy. So with copy, this is something we did in class. Where let's say you want to copy some list, right? Obviously, you don't want to just say like, let's say we have the list L. L contains the values 1, 2, 3, and 4. But let's say we want to make a copy and store it in the variable A. We don't want to just say A is equal to L, because then if we make some change to A, that change will be seen in both A and L, right? Because when you're saying A is equal to L, you're not just making a copy and setting it equal to A. You are making it point to a reference in memory that L is also pointing to. Or sorry, or pointing to an address in memory that L is also pointing to. Right? So you guys are both pointing to the same thing. So if one changes one thing, it's also going to be changed for the other thing. Right? And so that's where copy comes in. Where copy, all it does is it makes it so that you're able to, of course, copy a list and have it not have negative side effects to the original list. Right? The only time it's going to have a negative side effect for the other list is if the original list has nested objects within that list, right? So let's say the list itself, or the original list, contained the values 1, 2, 3, and 4. If you make a copy or a shallow copy, that's what it's called as well. If you make a shallow copy, you're not going to have any side effects if you change anything in the copy, right? But let's say now in our original list we have the values 1, 2, 3, and then a sublist containing 3, 4. We do a copy of that list. Then if we change the value of that sublist in the copy, that change will also be seen within the original, right? So to get something like that, you use the copy module. And within the copy module, you use the copy function. So you want to import copy. And let's say we have L is equal to 1, 2, 3. You're going to say A is equal to copy dot copy L. It's a bit weird. I don't know why they use the same names, but a shallow copy is represented by the name copy within the copy module. Bit weird, but yeah. So A is now equal to its own list containing the values 1, 2, and 3. So now if I change, let's say, a sub 2 to be equal to 4, and I print A, its value is going to be 1, 2, and 4. And then if I print L, L will be unchanged. It's going to be 1, 2, and 3. Okay? So this is what's known as a shallow copy, because remember, if the original list contains nested objects and you make a change to that nested object, the change will be seen in both the original and the copy. So an example of that, let's say I import copy here as well, and I say L is equal to 1, 2, 3. And then I say A is equal to copy dot copy L. Then if I were to say A sub 1 sub 0 is equal to, let's say, the character X, and I print A, then our resulting list is going to be 1, X, 3, right? But if we print L, our resulting list is going to be 1, X, 3. So we can see in the nested objects, they retain the changes that are made to the copy, right? So again, if you make a change to the original, that change will be seen in the copy if the change was made to a nested object. And if you make a change to the copy, the change will also be seen in the original if the change was made to a nested object. Okay? And that is what's known as a shallow copy. But if you want to get rid of those side effects and you want to make a complete and actual copy, where if you make any change, regardless of if there's nested objects within the copy, you make a deep copy, right? So this is a shallow copy. If you want an actual copy, you make a deep copy. So a deep copy also uses the copy module. So you're going to say import copy. And then let's say we have a list is equal to 1, 2, 3. I'm going to say A is equal to copy dot deep copy. And we're going to pass it the list. I don't recommend using list as a variable name because that's the method for creating a list, but for this example, it doesn't matter. All right. And then what that's going to do is it's going to make a copy. So now A is going to be equal to 1, 2, 3. And this is a complete copy, right? So any change we make to A won't affect list. So let's say I make A sub 0 is equal to 2. Now A will be equal to 2, 2, 3. And then L, or list, will still be equal to 1, 2, 3. Okay. Similarly, with nested objects, so let's say I import copy over here too. With nested objects, if I say L is equal to 1, 1, 2, and I say A is equal to copy dot deep copy, we pass L. And then if I say A sub 1 sub 0 is equal to X, then we are going to get the list 1, X2, but then L will be unchanged. So L will just be 1, 1, 2, right? And that's what deep copy does. So basically, deep copy only matters when there's 2-dimension lists or more. Yeah, you can have 3-dimension, 4-dimension, 5-dimension. If you're just working with 1-dimensional list, you can just use shallow copy. And then you won't have to worry about any side effects. But if you can have nested objects, your best bet is to use deep copy, unless you actually do want to change those values the within the, like unless you actually want to change the nested values, then go ahead. You should use copy rather than deep copy. Deep copy. It all really depends on what you're trying to do. All right. So, any questions about shallow copy and deep copy or delete? Any questions at all? One's typing. What's the alternate of deep copy? Um, I assume shallow copy. I'm not too sure what you mean by alternate. Like make an empty list. Like you mean just like delete everything in the list? I'm not too sure what you mean. Like make an empty list and move that onto the list. Yeah, I'm not entirely sure what you mean. Uh, I guess that would just be shallow copy if you're not like making an actual new list anytime you encounter a nested object. Yeah, manually copying the list. Yeah, you can do that too. Um, but if you want to do like the shallow copy way, then that's pretty easy to do. If you want to do deep copy, you would have to make like a recursive function to do that. Because anytime you find a nested object, you'd have to recursively deep copy that nested object, which isn't exactly hard to do. You just have to say like if the current thing that you're looking at is an instance of list, then just call deep copy on that list recursively. Um, Yeah. Right. Okay, so I don't know. I don't know if there's much more to go over. Um, okay, I guess the only thing we didn't really go over was decorators, which I myself didn't really go over that either. Because I don't know if he's gonna give that. Let me see if I can bring it up here real quick. I guess, and I don't know, Andrew, are you still here? Do you know if he's gonna give decorators? Following a decorator is easy. Making one from scratch might be hard. Yeah. Do you know if he gave decorators on your exam when you took him? What is a decorator? That's like it's like a way to modify function code without actually touching the code itself. Yeah, even if it is, I don't think it'd be more than one. So I think you can just skip it if anything. But basically, it's just a way to modify behavior of a function without changing the function code. Yeah, basically what you just said. That's exactly what I've written down too. Um, yeah, wrapper before the function is called, func after the function is called. Yeah, I doubt he would give a question like this. If he did, I think it would just be um like one question. I wouldn't say it's easy to implement. I'd say it's easy to read, but probably hard to like remember how to implement. Oh yeah. Um, but yeah, honestly, I would skip studying that. If it shows up, I would just move on to other things. Because if you're not too familiar with like list comprehension, lambda functions, sorted, sort, um, args, quargs, positional arguments, keyword arguments, you should be focusing that. You shouldn't be focusing decorators. That is like a very niche question that if you were to give it, it would just be like one question that you could just skip because you have 140 points worth of questions. So, what about this question? Like how to do it, or if he's going to give that specific question? Will he give us a question like that? He can. I don't know. He can. It's even if he were to, that's like 111 stuff. That's crazy. Okay. But yeah. So I'm gonna skip decorators for now. If you want to study that on your own, you can. Um, because I don't really think that's like useful for our time. But I guess is there anything else that I didn't go over? Let me see. Decorators. Um. Will he ask theory questions like pointers and stuff? That I don't know. It's a good question to ask Andrew. No memory, like as in you don't remember, or no memory questions. Even he does, yeah. Did you go over the binary question? What binary question? Lambda sorting keys. Yep, we went over that. Lambda is pretty easy. like binary to base, I doubt he gives that. Didn't I think we like did that in class or something, but like no one was able to get it. Something like that. I don't remember. Someone also said that he won't be giving F strings or something. I don't know who said that. I don't know if they're still here. But like, will he? Yeah. So is he 100% not giving F strings, or what's up with that? He said probably not. Okay. Well, if he gives one, it'll probably just be like one question. So if you're not good with it, I would just recommend skipping it and going to like the main stuff. Any sorting algorithm? He said there's not going to be any sorting algorithms. So you can skip that too. Okay. All right. I guess, is there anything else that comes to mind to anyone? Um, I don't know what else I can cover. Matrix, that's not Matrix won't be on it. Yeah, he said no Matrix questions. Like like Matrix addition, Matrix multiplication. No, there won't be. You can get like a 2D list question, but that's about it. Okay. Sorry, someone added me in something.